Thanks everyone, and thank you for all the good words. Today I'm going to talk a little bit on the high level among different problems we may face during the development of applications that work with money, with fiat money, or with cryptocurrency money. So how we'll start? How to start with finances in the applications we are working on, and what can go wrong. Basically, a lot of things, almost everything can go wrong, as we tend to go with straightforward solution, but quite often go to premature optimization. And first thing we need to consider when we are working on any problem, regardless of the domain, is define basically what the problem are you solving, what is the domain of your application, what processes you have on the back office, what processes you have in your application, what user flows, and so on. And when we are talking about finances, usually we have some God objects, yeah? So we have the users, we have the different currencies, and we have ledgers. I will elaborate a little bit. So when we are talking about currencies, usually it's tend to be related to countries. And when we are starting to work on any problem or any project, first of all, we need to really sit down and think about problems we're going to solve. For example, which currency we are going to support. Are we going to support crypto or fiat? Are we going to have all currencies available for all users and all countries, or there will be some limitations? Which limitations will we have? Are countries allowed to deal with multiple currencies at the same time? And so on and so forth. When we are talking about users, it's quite important to define who is our main customer. For example, are we going to build B2B applications or B2C applications? If we're going with B2C application way, our main customer is basically the people who is using the system. When we are digging more into B2B way, usually it's not a user itself, it's some company or organization, and there is different set of attributes that needs to be implemented in that case, like roles, permissions, sub-users, who is allowed to do what, and so on and so forth. Pretty the same with the ledgers or wallets, or name it as you want. Usually, when we're talking about ledgers in more straightforward way, we are talking about user accounts. So what is user account? User account is the representation of user balance in specific currency linked to specific user, and so on and so forth. So if I, as a user, have $1,000, it means I should have the account, link it to the United States dollar currency, and to my user. And all operations which are going to be performed in my application should be really related to the account itself and shouldn't rely on user or currency or whatever. Also, when we are defining the domain and the boundaries on it, we need to think about back office and how they are working with money itself. Because when we say that our system have $2,000, it usually don't mean that we have $2,000 or $10,000 or $100 million in one place. It usually means that there are a couple of places that hold that money. Some of them may be in cash, some of them on the bank account or any other form. And that produces some complications for us as for programmers and developers who deal with that, because if our end customer wants to perform a transaction or withdraw something that exceeds the limit in objective world, we are going to have a problem, yeah, because we will try to send the transactions, there will be insufficient funds on the account or whatever, and we need to handle that in some way. In the worst case, it will fail for the end customer, which is also fine. Also, when we are dealing with the accounts, we tend to work with different operations like deposit, withdrawal, payment, transfer, currency exchanges, and so on. All of them have their own problems, and we will talk about that over the next slides. So first of all, we define the domain. Okay, we are a B2C application. We are working with one currency, for example, or several of them. There is no limitation over the countries. There is no limitation on the cash and so on. Okay, we are ready to go. What can go wrong after that? First of all, we need to think and model our application in a way that we have complete loop, yeah, for the money flow in the system. So all funds that is held on account in our system should be difference between all incoming funds and outgoing funds, plus our fees if we have any. If that don't match, it means we have a bug, we lose the money, we was hacked or whatever, and we need to be really aware of that and monitor that somehow. That might be not a problem for the cases when we are working with fiat currencies, but that's quite common problem for cryptocurrency exchanges and people who are dealing with cryptocurrencies. Here is the reason why. When we perform the transaction, we need to have an account connected to the server in some way that can accept that transaction. And that means that if someone will be able to steal the private keys or connect to the server or whatever, they can initiate the transaction, and that's it, it's done. There is no regulators, there is no central authority. Everything you can do just like decrease the funds from your financial account. And the common solution to solve that problem is usage of multiple ledger accounts. Cryptocurrency exchanges usually name it hot and cold storage. So the account that is connected to the server is named hot storage and usually contains only a small amount of the funds, like from 5 to 10%. And the rest of the assets are stored in some secured, probably hardware, sometimes software system that usually is not connected to the internet. And the main idea behind this concept is the fact that usually your customer don't really withdraw all assets from your exchange at the same time. Yeah, you have some inflow operations, you have some outgoing operations, but probably only in Ukraine where is some disasters and everyone trying to withdraw all the funds from the bank accounts. But in your application, in most cases, there would be no such situation, and some percentage of funds from the whole system will be enough to cover the withdrawals. And if you have a customer who want to withdraw 50% of your funds, yeah, okay, that's fine, you can manually handle that. Second thing to consider and think about is data structure and types. I think there are a lot of people here who work on different projects, some of them together with me, and they told me about how important data structures and types are. So when we are talking about modeling our account system, we usually pick up the fast and easy approach first. Yeah, we have some class named purchase, it belongs to the user, it has some amount, we have validation, it's numeric type, and so on. But even on this quite simple and straightforward example, we have at least one thing to mind about. And that thing is about type of the data for the amount field. I think everyone here knows why we should avoid usage of floats or something like that during our work with finances. Is it correct? Yes. Okay. So the reason is that we want to be sure about the final amounts we are dealing with, and that's why we are working with decimal here with precision 10 and scale 2. What precision and scale means? So precision and scale means the precision total number of digits that we have in the field at all, and scale number of digits after the decimal point. So if, for example, we'll write the shop or, I don't know, donation system or subscription system on the PRAC, we will probably use some quite simple and straightforward approach, and we will not need to have fields that are able to handle millions in hryvnia. Unfortunately, we don't have such donations in PRAC yet. Okay, the second thing to deal with is the monetary types and the rounding. There is two approaches we can go with. First approach is to define monetary type yourself, create some class money, include some models, create some arithmetic yourself, and so on and so forth. Define conversion and rounding mode manually. For people who don't know, there is really good thing in big decimal named different rounding modes, and I highly recommend to use rounding for round half even. It's closer to, it round numbers to the closer higher or level value, and if they are equal to the level 1. And in some cases that's enough. It will be pretty straightforward solution. But if you don't want to deal with all that stuff, there's another approach. You can use existing gems. Basically, I highly recommend MoneyGem, and they have a quite easy. They give you ability to define new currency quite easily. You just register your own currency and define the units, define the ICO code, some metadata, delimiters, and so on. And after that, you're ready to go. You can work with any money you want. It supports different adapters for currency conversion out of the box. So in most cases, when you're not building specialized financial application, it will be more than enough. And also it have rounding out of the box. And with MoneyGems, we are able to add some additional validation or hacks. For example, we can manually, explicitly fail if someone tries to deal with float in our funds, and we also add some additional validations if you want. Okay, let's talk about account. So here we have quite straightforward implementation of account based on a record base. We have some class, we have the balance itself, we have some methods to manipulate with that balance, like debit, credit, and so on, with some basic validations in place. What's the problem with that method? The fact is that if you'll try to run that in background jobs or in multiple threads or whatever, it will not end well in that case, because we will try to deal with the state that is not a thread safe in that case, and we don't really know what will be the final result in that case, because part of the thread or workers can read the data at one point of time, second one can read at other point of time, and we have basically the problem with race condition and not trace safe code. So how to deal with that? Atomic operation. We can do that via mutex. That's more straightforward and manual way. Or the most popular recommendation on Stack Overflow is Activator Transaction. But there is some problem with that under the hood. But for some cases, it will work out of the box. So in that case, when we'll go with the mutex approach, we will manually define mutex on the in the constructor until that. And also we will manually synchronize the data during the mutation. But in that case, it means that we need manually do that each time we change the data. So active record is not a best fit in that case, as it produces a lot of implicit state, as it produces a lot of accessor and it changes the state under the hood during the runtime. So if we'll deal with that, in some way it will be good to have some more solid approach. Okay, second part is Activator Transaction. So if you have some pretty straightforward logic that involves creation of object, it will be just fine. If some of things fail, it will roll back the whole transaction, but it's not working very well in the case when we have nested chains of different set of transactions. So if you have active record transaction inside the active record transaction, inside the active record transaction, inside the active record transaction, it will be pretty hard to handle the correct state in that way and perform the rollback in appropriate way. So the approach I suggest in that case is to create some entity, service object, class, or whatever that will operate via balances for the customers. So we'll have one place to rule all the state changes that can be thread safe, that can be handled explicitly. And in that case, we don't really rely on any active record logic on behind of it. So we can create some account balance handler or whatever, and with Mutex or with any other solution, we can manually change the funds of the account. But even that approach is not the best for a couple of reasons. First of all, we need to deal with the version of the object. So if we have the accounts that change the balance for needed amount and so on, hit save, we don't really know which accounts we are changing. We don't know if the original object was not changed over the time after we have read that from the database, for example. And there is a couple of strategies for that. Optimistic, pessimistic locking. The optimistic approach will be manually call the database and match versions, so we can have the additional field or attribute. Usually that's field in database. And each time we change the object, we increase the version number. And in that case, we can be guaranteed that we have appropriate balance after each transaction, but it solves only half of the problem. Because if something goes wrong, we fail with the error here. And this means we need to define our fallback strategy ourselves. From my perspective, that's fair enough, but probably a lot of you wouldn't pick up that case. The other things we need to consider is the ledger, the history of versions. As here, we only change the version number. We don't really know what changed and what was the reason of the changes. How to solve that? We will talk about that over the next slide. But before we'll go to that point of time, the last thing I want to talk about is the fact that in real world, usually we deal with asynchronous process. Yeah? So even if we send the banking transaction to someone, it's usually not instant. Even if we receive the successful result from the payout gateway, it usually don't mean anything. You need to be pessimistic enough and expect that everyone and everything will fail. Even if you send the successful transaction, you receive the response, maybe you receive some callback or whatever, and even after a couple of weeks, it may fail because people and world is not ideal, unfortunately. Yeah, and even if you send transaction with some data to the bank account and so on, and payout gateway says that, okay, all is fine, and our payout provider and their bank, like merchant bank, says, okay, all is good. The money was sent from your account. But it don't really mean anything until the funds arrive to the customer account. And if you don't mind that, probably you can suck. We faced that a couple of times, to be honest. We had a case when we sent a transaction to the Philippines, and like all was good. We received a successful callback, we received all the data, and so on and so forth. Account number was validated, everything was good, but there was only one problem. The customer entered the account number from the United States dollar account. And in fact, the payout system were defined it in a way that they were expecting the Philippines one. And they didn't have validation on their side, unfortunately for that. And we had the finalized state, we deducted the funds, reflected all in the version history and so on and so forth. And after that, like, we received somewhere from the customer support the response that, okay, each transaction didn't go out well, please manually cancel that, and so on. So when we're dealing with real world problems, we need to mind the fact that probably in the most cases they will fail, they will go in another direction than we planned. There can be some problems under the hood we even don't aware of. So in that case, it's better to plan our code and our system in a way that we deal with the changes asynchronously. We decouple changes from each other, and we have the complete history, and we have the ability to safely change and move the funds over the system. So here on that slide, we added one slide changes. We added the locked balance, and it solved a lot, very big amount of problems. Because usually when we perform any operation, we don't really deduct the funds from the customer. We just lock them. So we deduct from one field and increase another field. And that's it, until we receive the finalization and wait a couple of weeks that, okay, all is good, and we can safely remove the locked balance. We are safe enough to automatically roll back or process the changes. Otherwise, if we completely deduct that from balance, the only possible way to do that is A, automatically increase the balance, but I don't recommend to do that to anyone, and B, manually increase that, and that's also a bad approach. Because once you deducted the balance, okay, it should be reflected in the history, but there should be a reason why you increase that, and you can't just allow anyone do that from the admin or whatever, especially if you have the version history. So about the version history, when we perform the save, we can add some additional logic. Probably that's not the best place, but just to illustrate the idea. We cannot even increase the version. We can also create an object that holds specific state over the time. And basically, we can use that object in order to show the history of specific account over time. Because when we have withdrawals or transfer or deposit or whatever, that's usually quite different things. They have different metadata, they have different objectives, they have different life cycle, and usually you don't store all of them in one dot table. And when you need to have some unified view for the clearance, when you need to match balance at the beginning of the month and on the end of the month, version for specific account is probably the best place to look after. And if we'll go back, another advice how to deal with asynchronous process, use state machine. Define your process in a way that have some finalized states, like, okay, your order is created, your payment is received, your order is packed, your order is shipped, or your order is delivered, and defines valid events that move the system from one state to another. In that case, you can perform your operation in a way that you just change the state of the domain itself, or just change the state of the system, instead of manually going through different objects and updating the attributes or whatever. How that looks on practice? Usually, people are using champs for the state machine. Quite popular is ASM. You define your states, you define some initial state, you define events that change the state, and you also define the additional concerns, like in which cases to run, if there is any additional condition, what to do before, what to do after, from which state to which state performs the transition. And basically that's worked quite well, especially if you don't mix that with your active record model and have some explicit place to deal with that. In that case, you can just fire the event and have all the logic triggered under the hood, and that logic will be thread safe, and you will be in charge for that. If you're interested in that approach, maybe it's worth for you to check the event sourcing and RCNC talks and books. They go with idea of events much further, but on the basic level, for majority of the cases, ASM can cover a lot of your needs. So, short list of rules to summarize my talk. Avoid mutable state. Decrease balance in a way that you first lock it, after that deduct locked balance. Each balance change will be atomic operation, so you are aware about what you're doing and you assure you are not charging customer twice or once instead of twice. Use separated concerns, explicit state, define the state of the system via state machines, and rule we always forget, fail fast. It's easier to fail and after that manually resolve something rather than ask customer to return that Bitcoin transaction that was sent twice. Thank you. Basically, like, I prefer to have the separate model for that and manually create the object history. And if needed, we can archive it or like perform some clearance. But usually, if your system is not big enough, like terabytes of data, it works just fine. Another good thing about having the separate model is the fact that, for example, if you're dealing with paper trail, you have quite limited set of data, and everything is just a JSON field. Yeah, if you have the separate model, you have more control over that. And for example, when you're building your transaction balance changer or whatever, some balance manager, you can assign some reasons. You can pass the additional context inside the version. Like, okay, that was one version, that is another version. Why it changed it in that way? And it's quite important to have some additional context, especially when you have system that depends on other factors. For example, we are performing the refund for the payout or bank transfer, yeah? But we can't perform the full amount of, we can't perform the full refund because amount was deducted by bank for $10 or whatever. So we refund $90 from 100, and there should be some reason in the history for us and for the customer, because otherwise we need to manually go through all the versions, manually grab the data from the other collection, merge them somehow, and so on and so forth. And it's quite important when you have a refund process that can take a while. Because, for example, you're performing the clearance for the month, and you match all the outgoing transaction and all the deposits, and it should match, yeah? And the balance at the beginning, plus the calculations, and should produce the balance at the end. But when you have a refund that was initiated in previous calendar months, you have some extra unaccounted funds appeared from nowhere. And that may be a reason for customer to be worried, because they look at the clearance and ask, okay, why we don't have that money in previous month, and what they're doing in that month.